First of all, I deeply regret the fact that I wasn't able to upload any video since 3 to 4 days. The reason was because one of my mentors suggested me to take a deep dive into the subject and make a better content. Uh, while doing so, I realized I had three shortcomings. One was time, second was team, and third was the resources, mostly like the cost of it and the value which was under it, because everything has a cost. Having said that, I'll start today's topic, and today's topic is intestinal protozoan infections. And we're going to be talking about mainly Entamoeba histolytica and intestinal amoebiasis. So what does amoeba mean? Amoeba means change. Wow, that is so different, right? Like, so if somebody says change the way of approach towards subject or change your view towards the world, you have to say be an amoeba towards the world, bro. Okay. Talking about that, so this change in amoeba happens because of its pseudopodia. So every time it moves, there is change in its shape, and every time it moves, there is change in its shape. Then there are two types of amoeba. They could be either intestinal amoebas or free-living amoebas. When we get into the intestinal amoeba, which is a type of amoeba which is based on its habitat, we have the amoeba which could be pathogenic or it could be harmless. Here in the red color, we have the Entamoeba histolytica, which is the pathogenic form, whereas Entamoeba coli is the harmless person, like how it is blue color. Then let's talk about the free-living amoeba. The free-living amoeba, for this you just have to remember Balamutia. Wow, the name is kind of characteristic. Balamutia. So this is a free-living amoeba. Then now let's talk about Entamoeba histolytica infections, the pathogenic form which is mainly to the intestine. The thing is with Entamoeba histolytica, it could cause either dysentery. Always remember, there is a difference between diarrhea and dysentery. Dysentery is bloody diarrhea, whereas dysentery is bloody diarrhea, whereas diarrhea is just watery stools. Now, so Entamoeba histolytica can cause two things. One is dysentery, or it can cause amoebic liver abscess. Well, that is a different kind of story. Amoebic liver abscess in itself is a very different story. But now let's talk about the epidemiology. The Entamoeba histolytica is mostly present in the tropical and subtropical areas. Here I've made a globe remotely, and around the tropics I've made this green color distribution of it. Now, it's important that we remember the parasitic infections which are most common and they cause death in humans. So for that, the classical picture as showed by the Indian movie cinemas, where they say females are the parasites, which I'm conventionally against, but the female are the parasites, that's what they show. We can use that for mnemonic now. So considering females are parasites, and so the first parasite, which is the most common parasite which causes death, is the malarial parasite. So the Ma is the first parasite. First is Ma. Then second is sister. So what does second sister mean? Sister means schistosomiasis. And third is our, of course, Entamoeba histolytica. So Entamoeba histolytica is the most common cause of death in the world globally. Then there is approximately around 110,000 deaths which have been reported annually. Then going ahead, let's talk about the morphology. Always remember there are three things with Entamoeba histolytica. One is the trophozoite, precyst, and cyst. Pre-cyst. The thing about I want you to remember is tropica replica. Tropica replica. Sounds similar, right? So this is the one which is the replicating form of parasite which is found in feces, right? Tropica, you replica in the feces. Now, another important point is here I've shown a diagram where we see the invasive form. So what do I mean by invasive form is that it invades into the blood vessel and then it disseminates into different places. So that is the invasive form, that is the trophozoite. The thing is that it has a single nucleus and it has a projection called a pseudopodia, which helps it in changing its shape and also locomotion simultaneously. Then let's talk about the precyst. This precyst is an intermediate stage between the trophozoite and the cyst. Well, not very special at all. Well, you can just remember that it is an intermediate stage. Then you have cyst. The cyst is the diagnostic form. This is the keyword which I want you to remember, that cyst is the diagnostic and the infective form. So there is a difference between infective form and invasive form. Do you remember from my party wala doggy video, we talk about my dog throwing eggs at you in Echinococcus granulosum? Like that, here also it's the cyst. you can remember the shell which is around an egg, which is the infective form. So basically you can find homology there. So this cyst is the one which is the infective form to the humans, and it could be an immature cyst or a mature cyst. Immature cyst contains of 2 nuclei, whereas a mature cyst contains of 4 nuclei. It's a quadrinucleated cyst. Then that's the infective form of the parasite, the mature cyst. Then let's talk about other features such as the life cycle. The host, our Entamoeba histolytica, when it looks at human, it's like, you are the only my love. You are the only person which I'm going to stay all my life. So life cycle, it is a single, it completes its life cycle only in a single host, that is man. Then infective form is you have the mature quadrinucleate cyst, as I told you already. Mode of transmission, here I've made a remotely water looking stuff which is blue in color, that is fecal-oral route. And then it could also happen sexually by anogenital route or orogenital route, and ultimately it could also happen by vectors. So 3 ways of going to humans: by sexual route, by vector route, or fecal-oral route. So predominantly it happens through fecal-oral route. Now let's talk about how it happens to develop in human intestine. For this I want you to remember a very funny way of understanding. So this Entamoeba histolytica is a very smart guy. In the stomach it escapes, but in the small intestine it removes its dress, and in large intestine it colonizes. So what do I mean? In stomach it escapes means it escapes through the acidic content. Then in small intestine it excistation happens, and in large intestine there is colonization happening. But after the process of colonization, this Entamoeba histolytica can also, again from trophozoite, it could also become a cyst again, so as to be excreted in the feces, or it could just be shed off as trophozoites itself in the feces. So whatever happens, it will colonize or again get back to become a cyst, or it could be excreted as a trophozoite. So simply put, so our friend here is going to change its dress in the small intestine and get colonized around, say, in the large intestine, and specifically speaking, it's in the ileocecal region. Now, after colonizing there, the thing is that it will start in look. Now what could be, it could have 3 prognosis from here. Here the person could be asymptomatic, or he could have amoebic dysentery, or he could have invasive amoebiasis. Now wait, but before that, as I told you, it colonizes on the mucosa and it divides by binary fission. Now as I've drawn a funny diagram here, that it could be an asymptomatic person, or it could be an amoebic dysentery, or it could be invasive amoebiasis. In asymptomatic, the cyst passes, so it's seen in majority of the individuals that it does not cause any lesion and it is just transformed and thrown out in the excreta. That's the normal man there. Then you have the amoebic dysentery. Here it adheres to the intestinal mucosa and produces intestinal ulcers and dysentery. Then at last, now this is just invasion. This is just being present on the mucosa, but now at last it could invade it. So it would invade and go to the blood, and then go through the get access to the portal veins, and then migrate to the extraintestinal sites. So ultimately it will go to the liver and cause the abscess there. Now there's another specific process is called as infestation. As I told you, in the large intestine, after colonizing, these trophozoites can either be converted to cysts to be released into the to be excreted in the feces, or that of remain as trophozoites and be excreted in the feces itself. This story happens when ultimately this is healed. When the condition is healed, that's the only time which happens. And remember, the conversion of a trophozoite to cyst will only happen within the intestine, and after going outside, there is no process that the trophozoite will get converted to cyst. All this is great, but now let's talk about how is this dysentery actually happening and what's the virulence factor and all that process. When we talk about the virulence factor, I just want you to remember something called as NAG. NAG, like a snake, NAG. Okay, that being said, it's N-acetyl galactosamine. That is the thing which you have to remember. So N-acetyl galactosamine is the surface protein which is basically the amoebic lectin antigen. So what it does is it basically binds to the corresponding receptor which is present in the large intestinal epithelium or the vascular endothelium, and it also has adjuvant virulence factors such as amoeba pore, or that of cystine protease or neuraminidase. Basically cystine protease, as you know, is an hydrolytic enzyme, and neuraminidase is a metal metallocollagenase. But importantly than this is how the pathogenesis happens. Basically, this nag, as I told you, it goes and binds, right? So once after binding happens, there is as I've drawn here, you can see that there is colonization. There is colonization, and there is decreasing of oxygen tension. And the result of this, after this, there is adhesion. So here there is adhesion, where it penetrates the mucus layer and adheres to the large intestinal mucosa by, again, the means of galactan, whatever I told, nag, right? Then there is flask-shaped ulcers which are produced. So they produced these flask-shaped ulcers where there is a narrow neck and there is a broad base, and this is mainly seen in cecum. This is seen where, my friends? It's seen in cecum, right? And it could be superficial, deep, or it could be, it could be round, oval. It could vary in depth and size or something like that. Then ultimately it could invade, as I told you. Basically it went through the mucosa, it went through the mucus, now it's gone to the mucosa, now it's like, I need more, it'll go just deeper, and once it goes deeper, it'll go into the process of invasion and then goes to different organs, right? So this is again helped by a lot of cysteine proteases or hydrolytic enzymes, right? And after this, there is basically intestinal complications, because it has damaged intestine clearly. Now the complications is that, as I've drawn this shabby diagram, I guess, where there is fulminant necrosis, fulminant amoebic colitis, and basically there is necrosis. And after this, we talk about, this is mainly seen in immunocompromised patients, this fulminant necrosis, whatever happens. Then you have amoebic appendicitis. So enrouting the intestine, it could go to the peritoneum, or it could cause toxic megacolon or intussusception. Intussusception is basically one tube going within the other tube, right? Then we have amoebiasis cutis or cutaneous amoebiasis. It could cause skin lesions basically, and it could be mainly around the perineal skin, because there was more of sexual route, right? There was anorectal route, right? Then you have the amoeboma. So it could be an amoebic granuloma, which is found within the rectosigmoid region. It's basically between the mucosa and the submucosa. And then chronic amoebiasis can happen. Like there could be thickening or fibrosis or stricture formation. So the basic point is that if you look at this diagram, you'll basically get to know, right? You could see these, it could penetrate the mucosa, or it could penetrate to the submucosa, or it could go all the way till the muscularis mucosa, or it could pierce the whole of serosa, just penetrating the whole of intestine. That would be perforation. And so flask-shaped ulcer is something which is restricted to the mucosa and a bit of submucosa, whereas deepening extension of ulcer, which is something which is till the muscularis mucosa, and perforation is all the way through the the whole of intestine. So that's going to be the end of it. And let's talk about how it presents clinically. Clinically, there is nothing like, there is no sex specificity. It's not like it will happen more in males or females. It's affected equally. And talking about amoebic dysentery, the thing is, it has bloody diarrhea with times up to almost 10 per day. Per day, there will be 10 times of it happening, with a lot of mucus and pus cells. And amoebic dysentery should be differentiated from bacillary dysentery. There are a lot of differences which will be discussed later. And as we told, amoebic appendicitis can happen, or amoeboma can happen. If amoeboma happens, there will be an abdominal mass. If amoebic appendicitis, as you know, appendicitis will present as what? An acute right lower abdominal pain, and there will be fulminant colitis. So that kind of ends our process of part 1 of Entamoeba histolytica.